All right, guys, we're here in section 3.
Yep.
Right, and we're talking about really the basis of geometry here. We're talking about the kind of what we're leading up from the first two sections into this, where we're talking about if-then statements and building our logic here to be able to come up with deductive reasoning. And deductive reasoning is what we use for the rest of the year. This is what makes geometry what it is. This is why we cover geometry really in between Algebra 1 and Algebra 2. Everybody always asks that. And the purpose of it, even though this may not make sense right now, but the purpose of it is to build some mathematical maturity in you to where you can deduce these logical statements here and come up with reasons for these things and so on to be able to get to the things that you need to do in Algebra 2. And so we have inductive reasoning and deductive reasoning. So again, inductive reasoning is based on patterns. Once we see a pattern develop, we're going to guess what happens next. But in deductive reasoning, it is based on this statement is true, therefore this statement is true, because of that, this statement is true, and we know that it has to be true. So deductive reasoning uses facts, definitions, properties, and laws of logic to form a logical argument. And that's what we're trying to get you guys to be able to do is come up with a logical argument and think logically. In college, when you get to college, you can take courses on just logic. And so we want you to be able to develop those principles within you to be able to come up with a logical argument for things. So,
yep.
Yeah. So, within our laws of logic here, bless you, Mr. Dunn, we have the law of detachment. And the law of detachment says that if the hypothesis is true, then the conclusion must be true. And so back to Mr. Bedella's example of if it rains, then I get wet. So if it rains, if that's a true statement, if it does rain, then yes, I do get wet. Now I understand there's details to that. I'm assuming I'm outside and all those kinds of things, but we make those assumptions for that type of statement. So if it rains, I get wet. If the first one is true, the second one has to be true.
Or if we use the other one about the right angle, if it's 90 degrees, well then we know it's going to be a right angle. I mean, it's got to be that.
Yeah.
That's why that's what a right angle is. It's 90 degrees.
Right. Right. All right. This one's a little bit more complicated. This one's called the law of syllogism.
Love that word.
Yeah.
It's cool. It comes off the lips. Nice.
Yes. I don't know why it reminds me of syllable, but it's syllogism. And it has to do with really putting together two if-then statements in a row. And but they have to have certain properties within that, though. So if we put two if-then statements in a row right after each other that are tied together, and the way they're tied together is that the conclusion of the first statement has to match the hypothesis of the second statement. Okay, so basically we get a repeat going on there. The repeat is happening with the conclusion and then the hypothesis. And we end up putting together the original hypothesis and the final conclusion to come up with a statement out of that, a logical statement out of that then.
These ones are always fun to do.
They are. Yeah. It's kind of a puzzle type thing.
Yeah.
Yeah. So, as an example of the law of detachment.
Yeah. Now, it's my turn to talk here, but I'm gonna pass the buck over to Mr. Scritchfield because he's really good at explaining this problem where, this one's always been a struggle for me. So you guys are going to use the law of detachment to make a valid conclusion here. And it's basically saying if x is less than 12, okay, so if x is less than 12, that has to be true, okay, then, all right, we know that x minus 3 is less than 10, and Mr. Scritchfield will take it from there.
Well, again, we're going back to what we just said. If the hypothesis is true, so as long as we pick some number less than 12, then the conclusion has to be true also. And so they're going to give us an example to plug in, to try here. And so the example they're going to say is the value of x is 9. And the reason they're picking 9 is because it's less than 12. We couldn't pick 13 or 14 or whatever. We have to pick a number that's less than 12. What we're testing on to come up with a conclusion is, does that make the conclusion true also? So if we take that 9 and plug it in on the conclusion side, 9 minus 3 is 6. Is 6 less than 10? Yes, it is. And so based on the given example that they give us, we just need to come up with a conclusion out of that. And so when we're talking about algebra here, we're just plugging it in and seeing what the conclusion ends up being. And so in this case, it's just 6 is less than 10, which is a true statement.
So if they even pick the number 5, if they said the value of x is 5, would that still be valid with the law of detachment?
Let's plug it in and test it.
Okay.
5 minus 3 is 2. 2 is less than 10. Yes, it is.
Therefore works.
If we make the hypothesis false, if we pick 14, is 14 less than 12? No. If we plug in 14 into the conclusion, 14 minus 3 is 11, and 11 is not less than 10 either. So if the hypothesis is false, the conclusion is false here. Okay. But the law of detachment says if the hypothesis is true, conclusion must be true. All right?
All right.
Then we got the law of syllogism here.
All right, so we're going to use the law of syllogism to write a new statement. And so I had a student a few years ago really kind of put it in a way that kind of makes sense to me, and I'll talk about that in a moment here. But basically this one says, if you get help, then you will do better on your next test. If you do better on your next test, then your grade will go up. And so the idea, guys, is remember with the law of syllogism, we're looking for what he always called was the middleman. And kind of the middleman is the guy that's helping both parties. And so if you eliminate the middleman, then all you have left is the two parties that really need to speak to one another, or the two things that need to come together. So if you look at this again, it says if you get help, then you will do better on your next test. If you do better on your next test, then your grade will go up. So what you want to do with the law of syllogism is which thing repeats itself. I mean, that's what you're really looking for, and obviously it's the test. So if it's the second part of the first statement, then you will do better on your next test, and it's the hypothesis of the second statement of if you do better on your next test, there's the middleman, and so if you eliminate that, then all you have left is if you get help, then your grade will go up. So if I can present another example, if in a more of an algebraic thing here, if A equals B and B also equals C, well then we can take the middleman out, which is just B, and then say that A is the same as C. So I mean, it's just kind of this thing of, the conclusion of one is the hypothesis of a number of the other. Get rid of that conclusion hypothesis, and then just put the two remaining pieces together.
And we still come up with a true statement.
That's right.
Yeah. So, and we'll do more examples of that.
Yeah, these are fun. This next one on the next slide is really kind of cool.
Yeah, this is a kind of a longer extension of it, but it's the same thing.
Yeah.
So law of syllogism. And again, kind of a puzzle here in a way. But you need to look at these as individual statements. So if Jenna does her homework, then she goes to the movies. That's one statement. If Jason goes to the movies, then he buys popcorn. If Jenna goes to the movies, then she buys popcorn. And we kind of need to end it there. We should have this come in separately. So those are the statements that we know to be true. Okay? Then again, kind of like the if X is 9 kind of thing, they give us an example of something happening. So they tell us Jenna does her homework. Based on that statement, we kind of plug that in to what's going on here, and we come up with questions or answers to questions based on this.
Right.
So our first question here is, does Jason buy popcorn?
You got to be careful here because he's kind of a distractor more than anything else.
Yeah.
And so can you actually answer this question based on factual information in that question? And the answer is no, you can't.
No.
Because we don't know if he went to the movies or not.
No. It says Jenna does her homework, but that's the only example that they
Right.
gave us, the only true statement out of here that they
Right.
give. They didn't tell us anything about Jason. We have no clue what he's doing.
Yep.
So that answer is no. Okay. Second question, does Jenna buy popcorn?
Well,
Do we
she
know
did her
that?
homework.
She did her homework, so it says if she does her homework, she goes to the movies. What's that got to do with popcorn?
Well, later on it says if Jenna goes to the movies, then she buys popcorn. So basically, by the law of syllogism, if Jenna does her homework, she goes to the movies, and then later on it says if she goes to the movies, then she buys her homework. Well, the middleman goes to the movies, so you can dump goes to the movies and just slide if Jenna does her homework, then she buys popcorn.
There you go.
And so the answer is yes.
Yes. All right.
Pretty cool.
Third, final question.
We're just math nerds, guys.
Yeah. Yeah. These are good puzzles. They just
fun.
are. Does Jason go to the movies? Who knows? Again, they don't tell us anything about that. If he does, he buys popcorn. We know that, but we don't know whether he goes or not because it doesn't say that. So the answer here is no. Again, it's kind of a distractor to have the Jason in the middle there just to maybe throw us off a little bit.
Well, and I think it proves a good point about geometry is we only say things that we can prove.
Right.
We're only going to make statements, guys, that we can prove in geometry.
Yeah, we have no clue on that one, so
Yeah.
we can't conclude anything.
Yep.
All right. Okay, so we're going to do more examples of that
Yep.
in class on our assignment and so on, and so we'll work through those, guys.
All right.
We'll see you in class.